Hello, my dear students. Welcome back. I know. Exams are just around the corner, and things are getting a little stressful. But hey, don't you worry one bit. Today, we're going to take a little break from all that pressure and revise a really fun chapter with a nice story. Ready? Let's get started.
All right, so let me introduce you to our friends for today, Soni and Avi. They're off to the amazing Surajkund Mela with their Dada and Dadi. We're going to tag along and see what kind of math magic they find hiding in all those colorful shops and fun rides.
So, as Soni and Avi were wandering through the fair, they started noticing these beautiful patterns everywhere. I mean, from the decorations to the Rangolis on the ground, everything had some kind of cool design. And their first stop was a stall selling these lovely beaded necklaces, or malas. Okay, now you guys look closely at these malas. See how the beads are arranged? They have different patterns, right? Soni and Avi noticed this too. Some of them looked, well, perfectly balanced, and others, not so much. And this little observation, my friends, is our entry into a very important idea.
This brings us to a big question, one you might definitely see in your exam. What is a symmetrical shape? Now, before I tell you, just take a second. Think about it. What does it mean when we say something is balanced or exactly the same on both sides?
You got it. Symmetry is just when one half of something is a perfect mirror image of the other half. You know, like a butterfly's wings. And that imaginary line you can draw right down the middle to split it into two identical halves, that's called the line of symmetry. If you were to fold the shape on that line, the two halves would match up perfectly.
So let's look at this side by side. In the first mala, see, if you draw a line right down the middle, the pattern on the left is a perfect match for the pattern on the right. That's symmetrical. But look at the second one. The two sides, they just don't match, so it's not symmetrical. Simple, right?
Next up, Soni and Avi came across a painter. Soni wanted to get her picture made, but let me tell you, this painter was a bit of a trickster. This little story is such a fun way to remember what a mirror image is. Let's see what this painter did.
After a little while, the painter showed Soni the picture. But wait a minute. You guys take a look. Does this look finished to you? What's wrong here? That's right. He only drew half of her face.
Soni was obviously surprised. She said, "Hey, this is only half." But the painter, being very clever, said that her face is symmetrical, so he only needed to draw one half. He told her to just put a mirror on the center line and she'd see the full picture. Ha! He used symmetry to do half the work but wanted the full 200 rupees.
But Soni? Oh, Soni was even smarter. She just took out a 100-rupee note and gave it to him. And when he said, "But this is only half the money," she used his own logic against him. She said, "The other half is exactly the same. Just put a mirror next to the note to get the full 200 rupees. Ha! A perfect tit for tat. Moving on from that funny incident, they saw some amazing Rangoli designs. Now, this is a fantastic example of symmetry in real life and in art. Can you imagine where you would draw a line on these Rangolis to split them into two perfect mirror halves? Some of them, like that first one, might even have more than one line of symmetry. Hey, this is something you can totally try at home. It's the easiest way to make something perfectly symmetrical. Just grab a piece of paper, fold it right in half. Draw one side of a design on the fold, and then cut it out. When you open it, it's like magic. You'll have a perfect symmetrical shape, just like this cat mask. So, as Soni and Avi kept exploring the fair, they started noticing the beautiful patterns on the ground, on the pathways, and this led them to their next big math discovery. Okay, so this next concept is called tiling. There's a fancy word for it too, tessellation, but really it's super simple. It just means covering a surface with shapes that fit together perfectly. The key is there are no gaps and no overlaps. Just think about the tiles on your kitchen or bathroom floor. That's tiling.
Let's go back to that picture of the fair's entrance. But this time, I want you to look at the floor. See those blue and yellow shapes? They are fitted together just like a jigsaw puzzle, with absolutely no empty spaces. This is a perfect real-world example of tiling. I promise, once you know what it is, you'll start seeing it everywhere.
So, after having a blast on the giant wheel, Soni and Avi turned around and, they couldn't see their Dada and Dadi anywhere. Oh no, they were lost. But you know what? There was no need to panic because they had something very, very useful with them.
Just then, they heard an announcement that their grandparents were waiting for them at a place called the Chopal. But where in the world was the Chopal?
Luckily, they found a big map of the whole fair. You know, maps are like secret codes that help you find your way around.
Now, the most important part of any map is its key. It's like the map's dictionary. It tells you what each little picture or symbol stands for. So take a look here. On this map, a car symbol means parking. A little tent means the shops. And that umbrella with the tables, that's the shop hall. That's our destination.
Okay, team, let's help Soni and Avi. We're going to follow these directions exactly. First, we walk on the blue lane. Got it? Then we take a right turn onto the green lane. After that, a left turn towards the red lane. And then the first left onto the golden lane. And there it is. Just past the stalls, we found the Chopal.
Phew! They found their Dada and Duddy, and everyone was so happy and relieved. What an adventure! You see, Soni and Avi not only had a super fun day, but their adventure taught us 3 very important math concepts. So, for your exams, let's do a super quick recap.
So, here are the top 3 things to lock in your brain. Number 1, symmetry. That's when an object can be divided into 2 exact mirror images. Number 2, tiling. Remember, those are patterns made of shapes that fit perfectly with no gaps. And number 3, maps. They use a key with symbols to help us find our way. If you remember these 3, you are all set.
Excellent job today, everyone. You learned so much just by following a fun little story. So I have one last question for you. I want you to look around today. In your house, on your way to school, maybe in the park. Where can you find examples of symmetry, tiling, and maps? Give it a thought. All the very best for your exams, my dears, and I'll see you in the next one. Bye-bye.